So when you guys looked in the back of the book and you saw answers, you saw something like okay, you see me doing everything correctly, right? There we go. I'm gonna just change this boundary real fast, make it less than parallel. Okay.
Should I press pause?
And it'll take like 2 seconds. Not like everybody watches my videos anyway.
How many subscribers do you have?
Huh?
How many subscribers do you have? 9?
I was told yesterday, actually, we were talking about yesterday, and I was told that my other class can help me get double digits, but I don't know if they did. Okay, so in the book, they did something like unit U plus unit V, or I'm sorry, vector U plus vector V. And then you had to graph it, so maybe here's vector U. And then they had some dots. And then they had the big one, and that was U plus V. And they also had V. And then they had some dots. Okay, so that's them graphing U plus V or graphing V plus U. So the top part, this is U plus V. And the red part is V plus U. They both end up in the same place.
At double digits. You got 10 subscribers.
All right. Thanks for your time.
Yeah.
U plus V or V plus U still gives you the same answer. So they did it twice. You don't have to do it twice. You can totally just do, where's my highlighter? You can totally just do U plus V and give you the U plus V, like just the top part. Or just the bottom one or something. They just did it twice, that's all.
Can you explain
Wait, can you
negative?
how do you graph these one off of the other?
So when we are graphing these, they're giving us component form. Component form is not the vector itself. The component form, oops, I'm going to make up some numbers, 3, -4. The component form is the change in the x and the change in the y. So if I have any vector at all, there's a vector, okay? And I want to add on this vector, then from the end of this one, I'm now going to go 3x, -4y. So 3 on the x is which direction? Right, okay? 1, 2, 3. And then we're going to go down 4. 1, 2, 3, 4. So from here, we're now going 3, 4. So I'm just going from one vector, added on to the next vector. Okay, so you're just building vectors here. And then like our final answer, whatever number that is, would be from start to very, very, very end of all of the vectors you've built. So yes. So that's it. You're just putting one vector onto the next vector, and that gives you that basic vector. So the negative, you would just do the opposite. So if I was doing something like subtracting 3, -4, if I was subtracting 3, -4, then I would really just be adding -3 and +4. So if I were subtracting it, then I would go this way and then that way. Okay, so you just go the opposite way. Okay? Now you did have to sketch 19 and 20. And then there's more that you have to sketch, but you probably should not have gone further than that, so you have to learn more. Okay, so you really should have gotten to about 20 if you did what you're supposed to do by tonight. So we're going to add on, and then you should have time to work in class and ask me more questions individually about where you're confused. But if you find vectors hard, you don't get them. They're really easy. I'm telling you. So if you don't get them, I'm not blaming you. I'm saying if you don't get them, ask questions. If you don't ask questions, what happens if you don't open your mouth? What is it?
Well, the mouth don't get big.
Hey, that's what his grandmother said, right? Yeah. That's why I said that. But closed mouths don't get fed. So if you don't open and ask questions, questions, you aren't going to get answers. Because I can't read your mind until it's on a quiz, and I'm like, oh, they didn't get this. And that's when I find out if you don't open your mouth. Alright, so we are on unit vector. And the unit vector is a vector that has a magnitude. What's magnitude stand for? What? Length of 1. Hence, unit vector. Length of 1. We can find a unit vector by using this formula right here that says multiply the original vector by 1 over the magnitude. Yeah.
Did we do this one?
The chart? There's nothing to do. It's just properties saying when you add vectors, instead of adding u plus v, you could, if you want, add v plus u. So on the picture, where I told you they did it both ways, they're saying you could add u plus v, or you could do v plus u, and it's the same answer. So these are just properties. Like if you take a unit or a vector and you add 0 on, you get that same vector. Like I didn't feel like we need to go through those, but if you need them, they are available to you. So on the unit vector, this is the formula to find a unit vector from a vector. You take the original vector and you multiply it by 1 over its magnitude. So here is finding a unit vector, vector v. The component form is -2, 5. That means from start to finish, from the first point to the last point, we go left 2, up 5. That's the direction the vectors go. Left 2, up 5. Now what we're going to use, we're going to find the unit vector. So we're going to find the magnitude of v. The magnitude is the length. How do we find the length? The distance formula. What is the distance formula? We don't have x2 and x1s and stuff. So it's the square root of the change in the x's, which is at -2, the component form, plus the change in the y's, which is what x2 minus x1 is, but we don't have that. We have after they subtracted them. And remember, I told you this last time, the distance formula, or the magnitude formula, is just right here. A squared plus b squared equals c squared, square root b. It's very important. So we're going to get square root of 4 plus 25, get square root of 29. So that is my magnitude. And we will write this as a unit vector. We're going to change this vector to unit vector. It says to take 1 over the magnitude as a scalar and multiply that by the vector itself. That's what it says up there. So I'm going to have 1 over square root of 29 and multiply that by -2, 5. It's going to give us -2 over 20 square root of 29, comma, 5 over square root of 29.
Can you act like the brackets are parentheses? Like they're basically the same thing. When you're multiplying.
Oh, you said add, and I got confused by what you meant.
If you add, so if you add, then I didn't read right.
Well, we did scalar multiplication, and it says if you are multiplying, then you just multiply each individual thing like this, so it's a lot like the distributive property. Yeah. So you kind of act like they're parentheses, if that's what you're asking. But they just mean something different than an ordered pair would mean. Okay. All right, and then for this, if you need to rationalize it, do you know what it would look like rationalized? Yes or no? How did I get that? Okay, so you know how to do that. So that should be the unit vector. How do we know it's a unit vector? No, what's the definition of a unit vector? What's on the paper? What's the definition of a unit vector? Has a magnitude of 1. And goes in the direction. Has a magnitude of 1. So to show that this really is a unit vector, we're going to find its magnitude to prove that it really does have a magnitude of 1. No. We found the magnitude of the original one, and then we used that to find the unit vector in the same direction. And then it says verify that the result has a magnitude of 1.
So what we just did was find the unit vector.
Yeah. This is the unit vector.
Not magnitude.
Well, we found the magnitude of the original vector
Okay.
to find the unit vector. Now it says step 2. Let's verify that this new vector really has a magnitude of 1. So we're going to find the magnitude of this one. We'll call this u because it's a unit vector. We'll just call it u. So it's like a new vector. And then we'll have the magnitude of u. We're going to show that that equals 1. I'm going to use this non-rationalized version to show that it equals 1. I'm not using the rationalized version. I'm using the one before I rationalized it, okay? It's easier. So we'll just do the magnitude formula, which is what? It's the Pythagorean theorem. Distance formula of the Pythagorean theorem. We're going to do negative 2 over square root 29 squared plus 5 over square root 29 squared. So we have the square root. When I square that, I square the numerator and the denominator, top and bottom. I'm going to get 4 over 29 plus 25 over 29. When I add fractions, I just add my numerators with a common denominator. Square root of 29 over 29, which is the square root of 1, which is 1. So there we have verified it, that there really is a unit vector. Yeah.
So I know the unit vector, but physically what is the unit vector? Like on a graph, is it?
Well, let's see. Negative 2, 5. That's the v. And that has a square root of 29, so that's about 5.4 units long. Yeah, that's how long that vector is. And then the unit vector would be the same exact direction. It's going to just be like 1 unit long. So the difference between this one and this one is the blue one is longer. So like the same exact direction, the blue one's longer. Or you could say that the green one was condensed down.
So it's kind of like probably like a parent. It's not like a parent function.
Yeah, exactly. Or if you think back to geometry when you did dilations, a long time ago when you did dilations, some of you maybe have done them. And you have a shape. Yeah, I was talking with her. When you have like similar figures and you have a shape, let me clone it. So these are what kind of shapes? These are congruent, but then you could do this to it. You could do this to it, and now it's a dilation. Or you could do this to it, and it's condensed down, but it's basically the same shape. That's kind of the it's there. Alright, and then these unit vectors, this is gonna like seem so overly complicated, and it's so easy, I promise. If you find it challenging, you don't understand it. Okay? If you find this hard, you don't get it, because it's easy. So ask questions if you're finding this hard. Okay, good prompt. Alright, so here, now you have a picture over here, mine's somewhere down there, so I'm just going to redraw things. But they're talking about specific unit vectors, and they're so special that they gave them their own letter. So this one right here is a unit vector, and it's already drawn for you. but the unit vector that starts at 0, 0 and goes 1 on the x, 1 on the x, nothing on the y. This unit vector j, so special they gave it a letter, and it goes 1 unit on the y, but nothing on the x. And then here they're talking about how we can change it from component form to what's called linear combination. Or we could take linear combination and change it back to component form, either way. So I'm going to show you how that's working, but I'm actually going to go backwards because I think it makes more sense going backwards. So I'm going to pick some numbers for V1 and V2. You guys can pick some numbers. Give me a number.
2 and 6.
Does anybody else want to help? Or okay, everybody. All right. So I'm going to say 2 is V1, and 6 is V2. So I'm going to go backwards of what they've done here. So the next step, if you look above it, it says you're now going to have 2 times 1, 0 plus 6 times 0, 1. Okay? I'm going to go one step above it, except actually there's a step that's not shown that I'm going to show you, and then I'll go up to that step. So the one step that's not shown is the one that I need to explain to you. So here, if I have a scalar outside of this unit vector, and I want to multiply them together, then I'm just going to multiply each number by 2. So we'll have 2, 0, plus, same thing over here, I'll have 0, 6. Now when I add those together, which you should have done in your assignment last night, you add the x's together and you add the y's together, and we have 2, 6. And that's our component form. Now, all I'm asking you to do is recognize that the component form here is the exact same as what's called the linear combination of the unit vectors. There. These are equivalent to each other. They mean the exact same thing. And you saw me work through it to see that they are equal. Well, you don't need to work through it. We just know that this one equals this, okay? Sorry, go ahead.
So if all of the I and the j next to whatever is always equal to.
Yeah, these are equal to each other. And that's because the unit vector, you're basically taking out a scalar from it and saying this is a scalar multiplied by a unit vector. And we don't have to write the unit vector because we already know that I is that every time. So here they ask you to find a linear combination, that's the I and j thing, of the standard unit vector. Oh, they said it right there. Didn't need to write that. We're going to find the linear combination for this particular vector. So we look at the vector, and we need to know the component form of this vector. So to find the component form, you subtract the second x minus the first x. So what's the second x? Does it matter? Yes, the arrow tells you. Second x is -1. You subtract the first x. Then you subtract second y minus first y. And we get u is -3/8. That is the component form. That is telling us that from start to finish, we are going left 3, up 8. Then we have to write this as a linear combination of unit vectors I and j. So we write, ready for this? -3i plus 8j.
What's the point of this?
For higher level stuff that we're not going to do. It's in Calc 2, and this is pre-calculus. So if you're seeing the pre stuff, you can take Calc 2. Let it hurt. Well, you know what? I mean, we can actually, they have, what's the word? Word problems with this whole. Real life application. We have real life application of unit vectors. Real life can give you some.
No, it was just funny the way you said you were like.
I know. This is my Friday mood. This is my Friday mood when I have been gone all week and I have to take care of my kids the entire week. Plus we have basketball game this week. Plus the parents teacher conferences made like and a 5-day week, like a whole 5 days a week. Alright. So that's it. Next, vector operation. You guys, let's see if you can figure this out without me even having to teach it. We've got u right here, v right here. We need to do 2u minus 3v. What do you think we need to do first?
Multiply like 2
2 times u? What else?
Would it be negative 5 minus 3 times?
What do you think we need to do now? Let's do it correctly. What do you think we need to do now? Now, if I needed to graph that, because you might have to graph something like that, if I needed to graph it, how would I graph that? If I needed to graph it, I'd rewrite it like that and go like negative 12 on the x, 19 on the y. See, this stuff's easy. If you're struggling, then you don't get something and you need to ask questions. I'm not trying to be mean and say you don't get it. I'm just saying, like, just ask questions because it should be. You don't get it. Okay, last thing. So, using a lot of other rules that we've learned in here, a lot of other things we've learned in here, we're going to apply trigonometry to vectors. Nah, we're not learning anything new. We're applying stuff we already know. So they have a unit circle, I have a unit circle for you right here, and here's the vector. And on the circle, remember that's the ordered pair x, y, but we also know that x is the cosine and y is the sine of the triangle. So we could also write that ordered pair as cosine theta, sine theta. And when we talk about the component form of that vector, we're talking about the change in the x, change in the y. That would be x, y for the component form. But also, we could write it as that for the component form. Did I lose anybody? Isn't that a lot? Yeah, well. What's the length of that? How do you know? It says? Or because it's a unit circle. How would we find the length if we weren't sure? How would we find the magnitude if we weren't sure? We would do the square root of cosine squared plus sine squared. And gosh, that sounds really familiar. Like, haven't we learned a property that says cosine squared theta plus sine squared theta is 1? Oh, I remember. Good. So you can see that the magnitude is 1. Oh, tangent theta? What is tangent theta? It goes in order like when you were doing Fibonacci. Sine theta over cosine theta.
Like how cosine is sine and then tangent over secant and then.
No, she's talking about
like the properties. Yeah, identities.
Oh, you mean the Pythagorean ones?
Yeah.
Oh, I don't even know which ones they are. I used to know the formula sheet.
That's why it was lost.
Well, you're saying tangent and cosecant, but it's more like, or secant, but it's tangent squared.
Right.
And secant squared, so I wasn't even thinking that way. Okay.
So you had a bunch of money.
Well, I wasn't blanking out, I was just confused. Tangent theta is equal to sine theta over cosine theta. Okay. They're gonna ask you some questions that seem so complicated, but up here, this looks really complicated. It's not. Oh, I forgot to say one more thing. Over here, theta, that's our angle. They're gonna call it the direction angle. Because vectors have to do with direction and magnitude. So that's gonna be our direction angle. But you've already learned those angles. So if we have something that looks like any of these, only they're going to give you information. So I'm just going to show you something that might look like that one. If we have 6 cosine 35 degrees I plus 6 sine 35 degrees J, what would be the magnitude? 6 would be the magnitude. What would be the direction angle? 35 degrees. If they're going to ask you questions like that, because they're going to take this form and write it in different ways. Here's our unit, and then this one has a scalar to make it longer than a unit. So they could be longer than 1 unit, but that would be the magnitude of it. You could also break it down to the linear accommodation with the I and the J. There's just different forms of writing these so that you're going to be asked questions about. And then you're also going to be asked to find the direction angle given linear accommodation. So it's the last thing that we're going to go over. They're going to ask you to find the direction angle, and they're going to give you the linear accommodation. So they're not writing it in the sine cosine formula, so you can't see what the theta is. So we're going to do it a different way. I'm going to think about 3 being the cosine. No, 3. And then 3 sine. That's telling me on my graph, my x is going to go 3, my y is going to go 3, and I'm going to have this vector q right here. We're going to find theta, which is right there. We're going to do this by saying, well, tangent of theta is equal to sine theta over cosine theta. So for this particular picture, I know sine and cosine are going to be 3 over 3. So the tangent theta is equal to 1. The question is, what's the angle? What theta?
So, how did you know that the cosine should go with the I and the sine with the J? Or does it?
Because of what we just did on the other side here, where this is the x value and this is the y value. And then remember when we write the linear combination, the x just goes with the I.
Okay.
Yeah. So that's why. Okay, so my question now is, where is tangent 1? 45 degrees. And you would know that because this is 3 and 3. If x and y are the same, it's got to be a 45 degree angle. So theta is 45 degrees. That's it.
How did you just like throw the cosine? You have the 3 and the I, but like why?
Because x, this is the x, and this is the y. And x is cosine, and y is sine. So I'm just switching things in and out that we've already learned in here. Right? We know sine is y. So I'm going to do the same thing again. So on this graph, what's my x value? What's my y value? -4. So that's going to be vector v. And we're going to find the angle. To find the angle, you're going to use tangent. And we're going to do y over x. So we'll put -4 over 3. I need to know at what angle tangent is negative 4/3. Is it on the unit circle? It is not. So yes, you will need the inverse tangent on your calculator to find the angle, not on your unit circle. Go ahead and do it. I'll go over it. Just waiting for people to catch up so everybody has the opportunity to try it themselves. You know how to do it later by yourself. Shine is white. If you can't remember that, you're paying attention. So, Avery, what'd you get? So that's telling me to start at 0 and go negative, but usually we don't give our answer like negative. So we're going to give our theta answer on this side. How am I going to find that side? 360 degrees, what? Minus 53.13. On my calculator, since I already have the minus 53, I'm probably going to do 360 plus my answer, because it's already minus, like add the negative answer on. And Taj, what'd you get? Oh, you ready first?
Was it 360 minus 53?
Well, it's 360 plus the answer, so we have more accurate decimal. 306 point what? 87. That's approximate.
Why did you do that? Like, why did you just do that? Or 50.
So it just depends on what the question is.
Okay. Oh, yeah.
I mean, they're the exact same. I'm trying to see if it specifies in there.
So you said,
It doesn't specify, but they're going to give you the cost. They're going to want the cost. But it doesn't specify. It doesn't say that. But
no, I was just saying, like, you can first, but it makes sense. You said, because you know, we apply the answer, so it's not like an oversimplified.
You still want the degree,
right, it was just making it process, yeah. So we have started this. Your job is to finish it and ask me questions about things you don't understand, because like I said, this should all be easy. And if it's not, you don't understand something, so ask. Okay?